All right. What kind of questions should we cover? 10? You got it. Number 10, is that the one that's root 128? Or am I on the wrong page? Oh, okay. I'm totally on the wrong page. What letter is it? I that we're on?
Yeah.
J. 127. 127. All right. Fast forward through your notes. Number 10, you said? Number 10, we have 1/2 over root 6. These are always everyone's favorite. Doesn't matter what class you're in. Everybody hates when we pull this 3 terms of a fraction garbage. It's just, we're just mean people that we like to give you this kind of stuff. All right. This is how I'd always approach this kind of problem. Unless you have this, everything looks like it's even like that. So I would just do this. Is that okay so far? So then you have a fraction over fraction. So you have 1/2 times, do the reciprocal of that, which is this. So that's going to give me this. But then we get caught in the snafu of, hey, can't have a radical in the denominator, so let's multiply top and bottom by root 6, root 6. So 1 times root 6 is root 6. And that's root 36, which is 6, times 2, which is 12.
Yeah.
Is that okay?
Yeah.
What else do we see?
22.
2. What?
I forgot to pull it out.
2. This class isn't all about you today. Other people are here. I know most days it's about you. Get your butt out, man. What number am I doing? I'm so sorry.
22.
22. 22. All right, some of you said you didn't get this whole conjugate thing.
Not at all.
Okay, so this is going to be a conjugate problem. First thing I would probably do on this problem, because I'm a math dork, is I would group that. Is that okay? Is there any questions on that?
No.
Olivia, you with me? All right.
I understand.
So what are you saying you didn't understand?
I don't understand.
Oh, Hannah, what happened?
I'm just confused.
Are you okay with the blue?
Understand the other day.
Yeah, that's easy.
Okay, so we're good there?
I think I get the concept, I just don't get how to do it.
Okay.
Yeah, right.
All right. So the conjugate of 8 minus root 3 is 8 plus root 3. You have to multiply both top and bottom, because if you multiply top and bottom, it's the same thing as multiplying the fraction by 1 if you're multiplying. So you're not changing the fraction. So on top, I'm going to get negative 80 minus 10 root 3. Is top okay so far?
Yes.
Now let's go to the bottom. So if we multiply the bottom, 64 plus 8 root 3 minus 8 root 3 over negative root 9, which is just 3. Is that okay?
What? Yeah.
Root 9's 3?
Yep.
Yeah.
Okay. Those cancel. 64 minus, so I get 61. Done. Check to see if you can reduce. You can't. 61 will go into 10 and 80 both. Okay, yes, 1 does. But what else? Yeah. 11. Oh, that's one of our faves again. Okay. Again, I don't know why they were demented and perverted like this, but you can put that over 1. Is that okay so far? You guys hold hands? Okay. All right, so then I'm going to get this. Is that all right so far?
No.
Anyone stuck on that?
No.
All right. So that means I'm going to have 1/3 root 3 over root 2. Is that okay? I can't have that root 2 on the bottom because, you know, someone in math said it was a bad idea. So then I get 1 times root 3 times root 2, which is just going to give me root 6 on top. And then I get 3 times root 2 times root 2. Root 2 times root 2 is root 4. Root 4 is 2. 2 times 3 is 6. I cannot cancel inside outside. I'm sorry, I'm hot. One cold.
It's freezing
I'm
here.
so cold.
I'm pretty
You
chilly.
wanna wear the vest?
I'm also wearing like
Dude, you
wear
can
that vest.
wear the vest, man.
The
Yes.
best.
The best.
The vest.
Wear it. Wear it.
You know, really
Don't mind
doesn't-
the pack of
it
cigarettes
really
in the
doesn't go
pocket.
with the pants.
Do not take it. Do not touch his dip. Okay.
You said dip, right? I'm sorry. How that came, I was like, dude, did he just say
I just think this is really crossing the
Can you tell a story to that?
line.
Sure. All right. What's the next one?
Lord
They
God.
are the same-
Nope, not yet.
37.
37?
I'll get it.
Compare it.
30.
I want a whiteboard. See you better.
Is that the one you wanted to do?
What about?
That's right. All right. That's right. Yes.
Yeah.
Cool. All right. Multiply both sides by 3 over 2. Those cancel, so I get x squared is equal to, that's 27, root, x equals plus or minus root 27. 27 breaks down to 3 and 3 and 3. So 2 of those make a square root. Done? Any others? Yeah. 12. Bless you. All right. We could go through this a couple of ways. Maybe we could make it this. First off, is that okay?
Yeah.
Okay. Some people want to get ahead of things and say, well, we can go to that. So we could either do one of two things. We could break up 8 into a perfect square, or if we could realize we could multiply both top and bottom by root 2. Some of you are going, where did that just come from? Well, it's the same thing as 1. That gives me root 16 on bottom. What's root 16?
Or
4. And then I can go here, so I wind up with 2 root 2.
Whoa.
okay.
Anything else?
No.
Yeah.
26.
2, 6. All right. All right. Anna, you still don't like these? You still okay with that?
Yeah. I am paying attention. Olivia's just pointing my view.
Don't blame Olivia for stuff you're doing. All right. So 2 plus root 2 is the conjugate. I have to multiply that both top and bottom. Is that all right so far, everyone?
Yes.
All right. 2 times root 3 is 2 root 3. Root 3 times root 2 is root 6. Root 6 won't break down any further. On bottom, if I FOIL it, I get 4. The outside and the inside go away. Minus root 4, which is 4 minus 2. That's 2. And I cannot reduce any all outside, so we're good. Anything else?
No.
Make sure your name is on that. Anything else you're passing forward, please?
Can't they just read when I see it?
I'm not sure.
Think they're reduced?
Do what? This one?
Yeah, because the dudes cancel out.
So I guess technically you could make this root 3 plus root 6 over 2 if you wanted to. I would accept both answers, but
Hey, like, you want to turn in before the age of
That's exciting.
Dude, you seriously just stepped on my face.
No.
But yeah, what you got?
On
You got some cheese.
Thursday.
Good.
Good.
I do stuff.
I'll be turning in 5 p.m.
Don't you be fibbing like that.
Friday, and I told my mom that I don't have Effie. And it's just gonna be really bad. Really bad. I know. Also, I They're just like, it's fine.
All right.
Yeah. She was so.
Everyone's okay? No, I got a lecture first. If I get through the lecture, maybe there might be time for something silly.
We never even got notes.
Do what?
We never even got the notes.
Oh.
And stuff.
Because you. See, you've already wasted my time. Now I have to hand these out. That takes away some story time.
You can just tell us story now.
Yeah,
I want you to pass
I need.
Let's see. Do I have a quick story?
I know you do this. You're a story man.
I got some good stories.
Let's
Just
hear it.
life adventures. It's just sometimes people get offended by it.
What?
No one will get offended today.
No one's offended today?
Yeah. We'll be offended if you don't tell the story though.
Okay. Let's see.
Or one short.
Did I pass out enough? Everyone's appropriate? I didn't.
No.
Really?
Really?
Right. Grant. All right. Oh, jeez, 2 rows. Holy cow. Can't take me anywhere these days. All right. So we're gonna start developing how to solve these. Most of you remember from Algebra 1 that if you take the square root of both sides, you wind up with 2 solutions. Okay, so that basically means that it would cross the, if we had xy axis, it would cross the x-axis at both positive and negative 8. Okay, but now we're going to go into a different thing. Let's take us back in time. You remember back in kindergarten? Remember those little times? I don't know if the last time you've been in a kindergarten class with Joanne going, there's no way I was that small. Of course, I was 16 when I was in kindergarten, so I was like this height. So. But when you were in kindergarten, do you remember you had like 1, and then there'd be like an apple, and then like 2, and that might be like trees, and then 3, there was, 3 hearts, something like that. So they were just showing you how you were counting, and that was basically a number line. And someone said no, they didn't have that in kindergarten. Well, not everyone went to the advanced one that had without the pictures. So you have been seeing number lines all along. And then perhaps when you got to first and second grade, the number line might have extended a little bit further than 10. It might have gone up to 20 or 100 or whatever. And by the time you got to 3rd, 4th, or 5th grade, perhaps you might have seen negative numbers incorporated into it. But what we do with these is we use number lines to represent regions. And we actually take 2 number lines, put them together to create something we call the Cartesian plane, which is your xy axis. And that's basically 2 real number lines that exist perpendicular to each other to find a distance. Well, we've only been using the real numbers all the way through. And they're like, of course they're real, I can see them. I know. They're actually called that. Their actual proper name is called the real numbers. But you might probably heard counting numbers and integers and rational numbers and irrational numbers all along. Remember hearing all those? And you're like, I remember hearing it, I don't remember what it was. Counting numbers were 1, 2, 3, 4, 5. Whole numbers was a much bigger number system because you included 0 in the counting numbers. So it went from 1 to infinity to 0 to infinity. So you included one whole more number. And then you had your rational numbers, which are your fractions and your decimals that could be written as fractions. Then you had your irrational numbers, which were numbers like pi and numbers like the square root of 2 and numbers like square root of 3, those are irrational numbers because you can't write it without the radical sign and make it a fraction. But now we start getting into the adventure of the complex number system. This is a crazy number system that is way larger than the number systems you've ever worked with. Okay? And a lot of times we call complex numbers, part of them are called the imaginary numbers. And that's what happens when I take the square root of this. Do you remember when you were in Algebra 1 and you might have gotten this and you put the answer NRS for no real solution? And your teacher might have taken points away from you if you just put no solution because they wanted the word real in there. That was that you were having the understanding that we're using the real number system. But this answer here actually comes out to plus or minus 8i. I is not a variable. I stands for, it is an imaginary number. It just means we had a square root with a negative underneath it. Okay, so now you're like, dude, where are we ever going to use this? Oh, this is the way perverted part of this class. You ready? The complex number system is the interdimension number system to the real numbers. What? Okay? So it means between 0 and 1 dimensions, 1 and 2 dimensions, 3 and 4 dimensions. Okay? You're in the half, in the quarter, in the 0.3 dimensions. Okay, so you can't fathom what those look like, but mathematically you can represent it. All right, I know that you don't have this table, so if you would, copy this down. Okay, so if R is a positive real number, and we should make that a capital R because that's the proper name for it, then the square root of negative R is equal to I root R. So this would be I root 5, and this would be 2I. The reason that's I root 5 is because I don't know what the square root of 5 is. It's 2 point something. But the square root of 4 is 2, but I have this negative under there. Okay? Now, as you're copying this down, I'm going to distribute that here and here. So I get I squared, and what is root 5 squared?
5.
Just 5. So then I get 5i squared. And just for right now, I'm going to call that negative 5. And you're like, dude, where did the negative come from? I'll get to it. Okay, and then this one here, that's going to be 9. And then I squared. So for right now, I'm just going to call that negative 9. And you're like, dude, where did the negative just come from? Again, I'll get there. So again, I know you don't have that slide available right now. But there was a spot for it, I believe. Is that true? Mm-hmm. Yeah. Okay. You didn't want the vest? I thought you were cold.
Yeah, but it doesn't go with the pants, you know? You gotta go with the whole vibe. Sorry.
All crumbled up.
Sorry.
Yeah.
I folded it.
Do that.
I folded it.
Tk you.
Yeah.
He gave you a vest.
I know.
You didn't.
Well, I felt bad because you were cold. I was
Thank
like,
you.
She did that to herself.
I
boyfriend.
Chivalry isn't dead.
The roof. Get the roof
I
out of
hate
here.
that one. That's so hard to say. But what?
can I move off this slide?
Chivalry is not that.
It's
It's
like,
like
you want to see a real
chivalry.
Too much art.
Chivalry, yeah. Dude,
This is do I get extra credit if I make this?
Yes.
What's the noise and oyster?
But you have to repeat the class. No.
All of them.
Crazy. Put it in right now for you.
I hold you to that.
You got it. Hey, Mr. Romano, one time I got extra credit in your class. I want to use it now.
I hate him.
I do.
Get right now. We ready? Set? Can I move on?
Yes.
Almost.
Almost?
Coco was in the
and I get to use it.
What's funny is Cooper's sitting there, he's got nothing.
Really?
He's got nothing.
Actually, the whole table
Oh.
went to it.
Dude, you rock.
Even
And you made the basket.
I know. That's double extra credit.
Ready?
Wait, no, I ain't ready.
Yeah, I ain't ready. I love it. Got the kid from Tennessee using ain'ts and can'ts. Huh?
You're ahead of schedule.
I'm not ahead of schedule. I'm actually.
Have you ever met anyone from Delaware?
Yes.
What?
Pam and Jeffrey Politis.
Oh.
You're
Yeah,
so
because I
good,
was
man.
thinking the other day, and I've never met anyone from Delaware or like Iowa.
Well, Iowa, you know what Iowa stands for, don't you?
What does Iowa stand for?
Idiots out wandering around.
What?
Idiots out wandering around.
What about
Oh, yeah.
Egypt?
Basically.
What about Iraq?
No.
All right, moving on.
So cute.
Sorry. All right, so here we go. See if you can pick up on this.
It's 9-9.
Real close.
I root 9.
What are the
Oh,
states?
plus or minus.
Oh.
Plus or minus 9i. And then this one would
Wait,
solve
their names were Pam and Jim?
Pam and Jeffrey Politis.
Dude.
They-
Jim and Jim. Jim and Pam.
No, not Pam and Jim. Jim and Pam.
Pam.
The legendary.
Is that all right? So I'm starting to slip this I thing in. Well, let's see, this one, just for the algebra, that's going to give me, what, negative 36. That's going to give me x squared equals negative 13. So then x is equal to plus or minus I root 13.
12.
12.
Georgia.
Who?
12.
How about
12.
Idaho? I know a ton of people. Idaho?
Pam Evans.
know anyone from Australia? Yes.
Yes.
I know a lot of Australians. Do you know anyone from Idaho?
Yes, Jim Becker.
No, you don't.
Okay. Indiana?
Yeah, Nancy Holmes.
My
My dad's from Indiana.
Indiana. All right.
I don't know you.
All right, let's see if we can figure this
How
out.
about Montana?
Okay, I'm done.
Yeah.
You're on my last one, I believe.
Done. Okay. And I get negative 3.
Shut up.
What about West Virginia?
Oh, you just. Oh my god.
My cousin Ian lives there.
Mr. Sir.
North Dakota.
This one's actually gonna stump you. Do you know from Georgia, not the state, but the country? There's that place in Europe.
Part of Russia. Used to be part of Russia, then broke
Yeah.
up.
Part of the
No.
Soviet Union.
Exactly.
South Dakota.
South Dakota? Yes, I do.
Oh my god, how do you know so many people?
Popular guy.
He taught Neo.
Yeah.
Travel with the crew. All right, we good so far? Eventually, I'm gonna get to a part where I'm gonna have to explain where this comes from. All right, let's see. You have a few things removed out of here, right? Let's do this.
Now that makes sense.
All right, I believe you have all of this.
Let me know.
All right, I'm not sure, other than reading this, how good it's going to do you. I think I can get to it on the next slide. So, you have a real part and an imaginary part of these numbers. Okay, and again, these are. If I had a square root and it had a negative underneath it, I get the letter I as part of it. And these are all examples for it. So you have the real portion of, and then you have the complex portion. The real and the complex. This just has complex to it. What you could do is you could have a 0 out there, and that would be your real component. So real and then complex. Okay? What you get up and down like 45 times in 30 minutes.
This is the second time I've gone today. About 45.
I'm sorry.
I wasn't sure if I heard that too.
Like next time, just say it in your head.
All right.
need you to know what your students are capable of.
What'd I do?
Nothing. Never mind.
All right.
He gets up more than I do.
So very concerned.
Mr. Sir, he gets up way more than I do. I just want to know. You. Tendency.
All right. I want to get to a slide. All right. I'm going back to this slide right here. And I'm not worried about the words that are on there. So now I want you to just explain the whole I thing to you. Okay? I stands for the square root of negative 1. Is that okay so far?
Yes.
So if you had like this, that's going to give me 4i for an answer. If I had this would give me I root 7 for an answer. Okay, so it stands for, you use the I, it doesn't stand for a variable. You use it to represent the negative under the root.
Okay.
But then it changes. I squared is the same thing as negative root 1 times negative root 1. Because I is the root 1, the square root of root 1, negative 1, excuse me. I squared is the same thing. If I multiply those together, I wind up with an answer of negative 1.
What? Oh.
Yes. So I squared is just negative 1.
Negative 1. So anytime you see I squared, guess what you get to sub in now?
Negative 1.
Negative 1. Good. Come down a smidge. All right, so then I to the third is the same thing as I squared times I to the first. Remember your rules of exponents? If exponents are next to each other and you're multiplying the bases, you add the exponents. Right? So what is I squared equal to?
Well, negative 1.
Negative 1. So this becomes just negative I.
So it's all just negative.
Okay? And the last thing that comes with I is I to the fourth power, which is the same thing as I squared times I squared. And I squared times I squared is negative 1 times negative 1. And negative 1 times negative 1 is positive 1. And then, ready? See if you can figure out this pattern. I to the 5th, I to the 6th, I to the 7th, I to the 8th, I to the 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th. It repeats every 4. That's all it does. That's all it does. So it's not like there's much more to it than happens. Again, this deals with the interdimensional mathematics. That's really good stuff. Okay? Of course, I'm a math geek, so I like that stuff. I don't want to get that. Let's go here. All right. When we add, subtract, multiply, and divide, we combine i's as like terms. So this is going to give me 7 plus 8i. Done.
Oh, so it's just, okay.
This one is going to give me negative 7 minus 9i. Done. This one's going to give me negative 2 minus 2i. Did I do that right?
Yeah.
Remember, I have to distribute negative here.
Yeah.
Then this one, that's going to give me 6 plus 2. Uh-oh. I guess I could break that down to 2 root 3.
Yeah.
And so then I have 2i root 3 plus I root 3 is 4i root 3. And again, you're just combining like terms. Do I need to worry about fractions?
No.
Just because it's going to be all over your homework doesn't mean I have to do it.
Okay.
Are you serious? I'm just going to skip the fractions. Fractions suck. Okay. All right, ready? 6i squared. What's I squared equal to?
Negative 1.
There you go. There's your answer. 49i squared. What's I squared equal to? Negative 1. What's I squared equal to?
Negative 1.
This becomes 25 I squared. I squared is negative 1, so I get negative 25. Notice a lot of times when you have I squared, you get rid of your complex number. And then this is going to give me negative 3 times negative 1, which gives me just 3. And that's going to give me 8i to the third. And we said I to the third is equal to? Negative I.
Yeah.
And so 8 times negative I is negative 8i. So way different wackadoodle math. Stupid is dumb. Just gonna stand on the corner and beg for food. I'm gonna do that one summer. Just say like, you know,
That's horrible.
disgruntled math teacher or something like that. All right, ready?
Some days negative
Good?
Yes.
All right, we've just done this. Look back 2 slides for that one. All right, here we go. You should be good there. And you should be good here. Plus 6x minus 14x minus 35. Okay, these are just old school problems. We put these up so it's like, oh yeah, I remember how to double distribute. We've never seen that. Right? Can I move off that screen?
Yeah.
Good. Then we get to this. This becomes 15 plus 10i. This becomes negative 14 plus 9i.
18.
Yes, sorry. Thank you. I'm so glad there's people in here smarter than me. It'd be such a lonely place if I was the smartest person here. 6i plus 10i squared. 10i squared is going to be replaced by? So I get negative 10 plus 6i. And again, you want the real component first and the imaginary component second.
No.
So on the test, are you gonna like drop us off?
Heck yeah, you especially, because you asked. If I see it happen once on yours, I just give you 0 for the whole test. Everyone else gets partial credit.
That was an eventuality anyway, so.
What?
I'm kidding.
We're not sure. Just go with it.
it.
It was
All right.
gonna happen anyway.
Weird kid.
All right, here's our foil.
It's okay, Sam. I thought it was funny.
It's all weird.
Where'd that come from?
More fun.
Yeah, 6 times 3 is 18. I squared or I times I is I squared. So I get negative 18. Is that okay? Combine like terms. So 10 subtract 18 is negative 8 plus 36i. Done?
Yeah.
Okay. Same idea. Do you need me to FOIL this out?
No.
Are you okay with multiplying this out?
Yes.
Don't be like in Algebra 1 where you're like, oh yeah, it goes here and here. No. You have 2 plus 3i twice. You good?
Yeah.
Moving on. So those were all conjugates of each other. So if you multiply 2 complex numbers together that are conjugates of each other, they become a real number. Anyone need me to go through those, how I foiled them? We good? Can I move on? Man, I'm starving. Anyone have like Big Mac or anything?
Oh, yeah.
Let me pull it up.
Let me read it out.
All right. So here's our last favorite. Put it in parentheses first. Still with me?
Yep.
Yes, sir.
Okay, I don't like to have an I in the denominator. So I'm going to go 1 plus 2i on bottom and 1 plus 2i on top. Still with me?
Yes.
Yeah.
So multiply the top. That's going to give me 5 plus 10i plus 3i plus 6i squared all over 1 plus 2i minus 2i minus 4i squared. Where am I substituting in negative 1?
Anywhere.
Nope.
I squared.
So that's going to be a negative 1, negative 1. So that gives me a negative 6 right there. Combine like terms, 5 minus 6 is negative 1. Combine like terms plus 13i. That's on top. All over. Those cancel out. This becomes positive 4, so 1 plus 4 is 5. There's my complex answer. Cool. Sweet, 2 slides left on. Right on target. And then I could totally get a fun story for Cooper.
Yeah, you just line through it.
Wait, I'm just telling Cooper, I'm not telling anyone else.
Yeah.
Because he asked. Alright, can I move on?
Yeah.
We good? No fibbing?
No.
Yeah.
Even the quiet kid? I'm good?
Who's the quiet kid? I don't know.
There's several.
It's not necessarily several quiet kids. There's just some that are way louder than others.
They equal each other out. Do they? Yep.
You can equal this whole class out.
All right. Everyone okay with that? Multiply it out. What's going to happen on the bottom?
No turn. Cancel it out.
So, whatever this multiplies out to, the whole thing will become over 2. Why is it over 2? Because I times I is -1, and then I get 1 minus -1, which is 2. And then whatever this multiplied out to, oops, that's a -1 minus I. And then, dude, oh my gosh. Now we have this radical and i's. Are you kidding me? Do I sound like anybody in here?
Nah, bro.
Not dog.
Quality good.
All right. Everyone agree with that so far? Let's do a little math. Root 7 times root 7 is 7. Root 7 times that is going to give me 2i root 7. That's on top. On bottom, I get root 7 times root 7 is 7. The middle terms cancel out. Minus 4i squared, so plus 4i. Nope, plus 4. There's no I there because that would have gave me a negative 4i squared. Negative 4i squared is positive 4. So that's supposed to be a 4. My goodness. 7 plus 2i root 7 over 11. Check to see if you can reduce anything outside. That's right. So someone asked, could I have this? Why do you think I like writing it like this versus like this? Especially with y'all writing.
Not in the radical.
Yeah, so I don't want to put it in the radical. Okay, so that's why I put it first. One slide left.
Kinda.
Kinda?
Yeah.
What are you like?
What do you mean kinda? Like,
I mean, there's one slide.
okay.
Then why'd you say that?
I was like getting scared. I'm like, dude, I'm running out of time. I squared's what?
-1.
So this answer's -3.
Yes.
I to the third is equal to what?
-1.
No.
It's just one.
No.
I.
It's negative I.
Negative I.
My God.
I can't have an I in the denominator, so we're not going to multiply both top and bottom by?
Negative
Positive one.
I and I. So then I get 7i on top. What's I times I?
-1.
-1 times that.
1.
So my answer is just 7i. And then, almost done. 2 minus I. 2 minus I. So that's going to give me 6i minus 3i squared, so plus 3.
Oh my god.
Why are you dying so fast?
What happened?
No, it's not related.
It's
Don't
water.
worry.
Is it me?
No, it's not about you.
Of course not.
I would never.
You can blame me anytime.
No.
All right. So, ladies and gentlemen, tomorrow you have some sort of testing. So worksheet J is due on Thursday, right? J or K? K. There's a K there. Sorry about that. All right. So Cooper, you want a story for a minute?
Yeah.